we're going to go over conditional probability. So, conditional probability is given as a formula such as this. In the formula booklet, it's normally given with the letters A and B, but it doesn't really matter what letters you use. These are just two different events. So this literally means the probability of E given F, so the dash just basically means given F, is the probability that an event E will occur given that another event has already occurred. So we need to assume that F has definitely occurred. And this is the formula. So I will pause the video so you can write this down now. Now, this question, it's about a dinghy sailing team. The probability of strong winds tomorrow is 0.8. So we're going to have the probability of strong winds, probability of not strong winds. So I'm going to put dashes where it's not. So the probability of strong winds is 0.8. The probability of not strong winds is 0.2. And then it says in strong winds, the probability of Alan's team winning is 0.6. So then we've also got winning and not winning. So we've got winning and not winning, and it says 0.6. And then obviously in lighter winds, so this not strong wind, the probability of Alan's team winning falls to 0.45. So we've got the same branch repeated here, but we're going to have different values. So this is going to be 0.45. And obviously every pair in the branches must add up to 1. So we have 0.6, 0.4, 0.45, 0.55. Then we need to use the probability of conditional probability. So given that team wins, Alan's team wins, so we're going to say given that it wins, find the probability that the winds were light. So our definition of light winds is not strong. So it's going to be probability of S dash given W. So how do we write this down? Well, instead of writing this formula, we're going to write it again, but instead of E and F, we're going to write S dash and W. So we're going to do the probability of S dash N W over the probability of W. Now, because W, which is the winning, is dependent on the previous event, this is not a straightforward of picking 0.6 and 0.45, and that obviously exceeds 1 anyway. So to find out the probability of winning, and therefore this would be normally a 5 marker in the exam, you have to work out the probability of it being strong winds and then winning, and then the probability of being not strong winds and then winning. So you have to work out the product of both of these pairs. So the first one's going to be 0.8 times 0.6, which is 0.48. So the probability of winning, given that it's strong winds, is 0.48. And then the other one's going to be 0.2 times 0.45. So 0.2 times 0.45. That is going to be a little bit more challenging to work out. So that's a bit like saying 2 times 45, which is 90, and then make it a lot smaller. So you're going to make it 10 times 100 times 1,000 smaller. So it's going to be 0.09. So we've got our 2 key values now. We can actually start substituting them into the formula. If you haven't already copied this down, please do so now before I erase it. Okay, so the first thing we've got to work out is the probability of winning. So the probability of winning is going to be simply the sum of the 2 values on the right-hand side, which is 0.48 plus 0.09, which is simply going to be 0.57. 0.57, so that's the probability of winning overall, because it's a dependent event. And then the probability of it being not strong and then winning, we've already worked out. That's the numerator of 0.09. So we would write that on the top. And then all you need to do is plug this into your calculator and you'll get an answer to 3 significant figures. Pause the video and do this now. And you can see the answer is supposed to be 0.16, and this looks like it's more or less correct. So I'm going to pause the video and you're going to have a go at this question now, and then we'll go over it. The answer is 0.462. Now we're going to have a go at a problem where we are looking at a different kind of manner of approaching this. So let's go to a question where it's to do with Venn diagrams. find the probability of B given A. So how do you do this? First of all, we're going to draw out the Venn diagram. We're going to have a circle here, and then we're going to have a circle here. We're going to have events A, and we're going to have events B. So it says A is an odd number, and B is a multiple of 3. And then obviously we're going to have numbers on the outside. So it's going to be as follows. So A is an odd number, so we can have numbers such as 3, 5, 7 and 9, but obviously 9 and 3 are going to be multiples of 3, so they also need to go in the middle. And then we are going to have the other multiples of 3, which are going to be 6 here, and then 2 is not odd, nor is it a multiple of 3. We've already used up 3. 4 is not odd, nor is it a multiple of 3. We've used up 5. 6 needs to not go on the outside as it's already here. 7 is odd. 8 is going to go on the outside as well, and then we've already used up 9. So what's the probability of B given A? Now, when we're doing it with Venn diagrams, it's much, much, much easier because we're assuming we've selected A. So all you have to do is look at the A circle. So rather than using the formula, you can just do it with common sense. So the probability of selecting A, what you can do for this is just write how many options there are in A altogether. 4. And then you just write how many options are in B given we've chosen A. So it's like zooming in on a subsection of the whole Venn diagram. So this is clearly just going to be these two values out of 4. Now, if you were to do it with a formula, you are allowed to. So how would you do that? So the probability of picking A is going to be 4 out of 1, 2, 3, 4, 5, 6, 7, 8 numbers. Let's see if I agree. 2, 4, 6, 8. Well done. 4 out of 8. And the probability of picking B is going to be chosen now. But remember, when we're doing this formula, this top bit is going to be probability of A and B. So A and B clearly is just going to be the middle section, which is 9 and 3. So if we're having a look at 9 and 3, our answer is simply going to be 2 over 8. And then you can see that 2 over 8 divided by 4 over 8, because they've got the same denominators, actually just cancels to 2 over 4, which is the same as 1/2. We will be going over Venn diagrams in a lot more depth in future lessons.